Okay, so let's continue with our lesson. So the next question we have here, I've already copied it down for us, is if x plus yi, so we have a complex number where our two coefficients are unknown, multiplied by 2 minus I is equal to negative I, and of course that x and y are elements of the real numbers, find x and y. So, again, pause the video if you can, try it on your own. And now let's take up the solution. So, first thing I'm going to do is isolate this bracket that I'm looking for, right? I want to get all my unknowns on one side, all the numbers I do know on the other side. So I'm going to just do x plus yi, so my first bracket. And now because it's all by itself, I'm going to divide both sides by this bracket right here in order to get rid of it on the left side. So I'm left with negative I divided by 2 minus I. Now, I'm going to multiply by the conjugate because I'm not changing the value as long as I do the same thing on the top and bottom. So multiplied by 2 plus I. And now, let's keep it going over here. So I'm just copying the left side. Is equal to my denominator just becomes my first squared. So 2 times 2 just gives me 4. Minus, and then I squared will just be negative 1, so minus negative 1, which of course will just end up simplifying to 5, but we have plenty of time to do that. And then I just need to expand over here. So I've got negative I times 2, so I have minus 2I, and then minus I times positive I, which will give me negative I squared, and I squared is just minus 1. So again, continuing. X plus yi is equal to, now we're going to simplify the top as much as we can, so this just becomes a positive 1, and it's not groupable with my imaginary number, so my numerator just remains 1 minus 2I, and my denominator just becomes 5. And now what I'm going to do is write the right side of the bracket as two separate fractions. So I have it completely separated as a complex number. So I have my real component, which is just 1 over 5, minus 2 over 5I. And because I have both my coefficients, here we go, x is just equal to my real component, and y is just equal to the coefficient of my imaginary component. So therefore, x is just equal to 1 over 5, and y is equal to negative 2 over 5. And I've got my answer. Okay? So, let's do the next question. So the next question is actually from the handout. So one second, let me just get it in front of me so I can show it to you on the camera. We're going to be doing number 7 from your handout. So the question at the bottom of this page. Two complex numbers, z1 and z2, are written like this, where a and b are elements of the real numbers, are such that z1 and z2 is equal to 3. Calculate the values of a and b. So let's do this one together. I'm going to copy the question, and then I'll take a brief pause so you can pause the video to try it on your own. So I've got z1 is equal to a divided by 1 plus I, and z2 is equal to b divided by 1 minus 2I. So take a second and try it, and then we'll take it up. Okay, now let's take it up. So I'm also going to copy the other information that we're given, that z1 plus z2 is just going to give me 3, but 3 also gives me a second piece of information, right? It's 3 essentially plus 0I. I know it's not written because there's no point to write it, but that's indirect information that we're given. So we know that the real component of our two imaginary numbers, so z1 plus z2, will give me 3, and the imaginary will give me 0. So that's kind of like the logic that I'm keeping in mind as I head into this question, right? I want to write my two complex numbers as a sum of one of the other, so we will need to do a little bit of work there, and then eventually I'm going to separate them out into their real and their imaginary components, and then I'll have two values to work with. So first I'm going to start working this out. So z1 plus z2 will be equal to my two numbers over here. So my first complex number and my second complex number. And unfortunately, I can't really multiply anything right now. Or sorry, not multiply, I mean add. But what I can do is try to get rid of the imaginary number from my denominator. So the first thing that I'm going to do is have my, I'm trying to think here, should I factor out the a? I am going to factor out the variables. So first I'm going to just have a bracket 1 over 1 plus I plus b bracket 1 over 1 minus 2i. And for each one, because I'm not changing their value, I'm just going to multiply by their conjugate. So you don't have to show this step if you don't want to, but I'm going to. So this is going to be equal to a times, and inside my bracket I'm going to have 1 plus I times 1 minus I, 1 minus I, plus b. And remember, I'm allowed to do this because what I'm essentially doing is just multiplying each fraction by 1, right? Because as long as I do the same thing on the top and bottom, I'm not changing the value of anything. And I'm doing this again to try and get rid of that imaginary number in the denominator. So let's continue over here. I'll do a little bit of mental math over here to save myself a little bit of room. 1 times 1 minus I. And then I'm left with 1. Oh, this is going to be over 2 because I have 1 times 1, and then I squared, remember, is negative 1, but I'm subtracting it, so it will be 1 minus negative 1. So that's how I end up with it over 2. Plus, and then b, this will be 1 plus 2i over, again, 1 times 1 will give me 1, and then I'm subtracting negative 4i squared. So it's going to end up giving me 5, right? Because the negatives will cancel out once I square I, and then I'm just left with 4, so then 1 plus 4 just gives me 5. And now that I have this, I'm going to try and make this as neat as I can because I'm running out of room, but I'm going to separate each number into its real and its imaginary components. So my first term is going to just be, and I'm going to bring the a back into the bracket. So it would just be 1 over 2, but I'm just going to write it as a over 2 minus ai over 2 plus b over 5 plus 2bi over 5. Now this might look more complicated than it needs to, but it actually really helps me out because I'm going to end up with this and this, so the real component of my complex numbers, so a over 2 plus b over 5 is going to give me what I have up here, right? The real component of my imaginary numbers, 3, and then down here I'm going to have, oh boy, minus, sorry, I'm confusing myself a little bit, I've lost my spot, minus ai plus 2bi over 5 will give me 0. But I don't really need to include the I anymore. I'm just writing this for now because the I is just our imaginary component. So in reality, this is just negative a over 2 plus 2b over 5 will give me 0. I don't need to keep writing the I. So let me rewrite that on the next page because I'm not going to have room on this page to finish my calculation. So like I said, rewriting my linear system. I've got a over 2 plus b over 5 gives me 3, and minus a over 2 plus 2b over 5 will give me 0. And now, just to make my life easier, obviously you can, oh, sorry, you can't see what I'm writing. But obviously, just to make my life easier, I'm just going to multiply both the top and bottom by 10 because I just don't like dealing with fractions, but you can solve it however you would like to. So my new system, after I multiply everything by 10, will be 5a plus 2b is equal to 30, and then minus 5a plus, what do we have here, 4b is equal to 0. And now, obviously, I would just prefer using elimination because the coefficients of my a's line up, so I can just add the two. So I just get 5 plus negative 5, which would give me 0, and then 2 plus 4, which would give me 6. So I have 6b is equal to 30. So that means that b will be equal to 5. And now that I have my value of b, I can solve for my value of a. I'm just going to plug it into my top equation up here, just because they're both positive and I like dealing with positive numbers. But again, you can sub it into either one of these equations. So then I'll end up with 5a plus 2 times 5 equals 30. 5a is equal to 30, and then moving this positive 10 over to the other side makes it negative. So I end up with 5a is equal to 20, a is equal to 4. Okay, and took a little bit of work, but we have our answer. So we found out what a is and what b is, and just double checking actually, because it was a long question, to make sure I answered everything that the question asked for, calculate the values of a and b. Yes, so I did all the work I needed to. Okay, alright, so I'm going to stop the recording here. There's still one more part of this lesson, so make sure you give that video a view.